In this video, we're going to look at question 11 from your paper 1, which is on discrete random variables. The question says, Alex models the number of goals that a local team will score in any match as follows. And we've got our table below, which shows us the number of goals and the probability of scoring each of these goals. The number of goals scored in any match is independent of the number of goals scored in any other match. A. Alex chooses 3 matches at random and uses the model to determine the probability of each of the following. I. The team will score a total of exactly 1 goal in the 3 matches. Now we've got 3 different possible ways this can happen. We can score 0, 0 and then 1, 0, 1 and then 0, and 1, 0, 0. So let's start by looking at the probability of this first case happening. The probability that we score 0 is 3 out of 25, and we've got to multiply this by the probability we get another 0, which is 3 out of 25, and then multiply it by the probability we get a 1, which is 1 out of 25. So multiplying those 3 together gives us an answer of 9 out of 3,125. Now what you need to notice here is that the probability of getting 0, 1, 0 or 1, 0, 0 is exactly the same as the probability of getting 0, 0, 1, because we're just multiplying probabilities together, and in both of these cases we've still got 2 zeros and 1, 1. So therefore, to get our final answer, we need to multiply our 9 over 3,125 by 3 for each of those 3 possibilities to get a final answer of 27 over 3,125. II then says the number of goals scored in the first 2 of 3 matches will be equal, but the number of goals scored in the 3rd match will be different. So again, we've got a few possibilities here. The team could score 0, 0 and then not score 0. They could score 1, 1 and then not score 1, 2, 2 and then not score 2, 3, 3 and then not score 3, or 4, 4 and then not score 4. We don't need to go any further than that because the probability they score more than 4 is 0. So now we've got to work out the probability of each of these cases happening. So we've got 0, 0 and then not 0. So we've got 3 out of 25 times 3 out of 25 times 22 out of 25, because I've just done 1 take away my 3 out of 25. Then for 1, 1, not 1, we've got 1/5 times 1/5 times 4/5. For 2, 2, not 2, we've got 8 out of 25 times 8 out of 25 times 17 out of 25. 3, 3, not 3, we've got 7 out of 25 times 7 out of 25 times 18 out of 25. And finally, for 4, 4, not 4, we've got 2 out of 25 times 2 out of 25 times 23 out of 25. So these are the answers for the probability of all my different possible outcomes. So now, because any of these could happen, I could have 0, 0, not 0, or 1, 1, not 1, or 2, 2, not 2, or 3, 3, not 3, or 4, 4, not 4. I sum these all together using the OR rule to get a final answer of 552 over 3,125. Now finally, part B says during the first 10 matches this season, the team scores a total of 31 goals. Without carrying out a formal test, explain briefly whether this casts doubt on the validity of the model. Now, for them to have scored 31 goals in 10 matches, that means that there's an average of 3.1 goals per match, or roughly 3 goals per match. Now, if we have a look at the probability of scoring 3 goals, it's 7 out of 25. Whereas, if we look at the probability of scoring less than 3 goals, that is far more likely than scoring 3 goals. So this does cast doubt on the validity of the model. So for my answer, I've said the model suggests less than 3 goals per match is more likely.